Welcome to another Out of Spec Renew episode. Today we are back in Denver meeting with Kevin and his fantastic new project. So Kevin, you're going to take us around the whole project, all the specs you're going to tell us about, but more importantly, tell us why you choose a very low mileage DMC12 to start this new project.
Right. Yeah, welcome to, I'm calling this project Gigawatt, and this is a 1982 DeLorean. This is a customer build. This is a very special car. This customer has had this car for a very long time. He loves this car. It only has 611 original miles. So it seems like, why would you take apart a brand new car? Because it is. It even has the original tires with full tread on them. But this customer had trouble, like a lot of DMC owners, with the original drivetrain. So every time he wanted to drive it, it was just unreliable. So what we're gonna do now is take it into the future, which might be the perfect car for that, by making it electric, reliable, powerful, everything that we like to have in a car these days.
All right, so let's start with the basic. What type of setup are you going to go for?
So I love Tesla parts, Tesla motors. So this is getting a Tesla drivetrain. This particular car was perfectly suited for the Model 3 Performance rear drive unit. So it's a 980 serial number drive unit. What's great about that drive unit is it makes this a mid-engine car, or mid-motor car, because the motor is in front of the differential and the half shafts, whereas a small drive unit from a Model S or a large drive unit from a Model S, it's actually the opposite. The motor is behind the differential, making it a rear motor. But there's a great location, and we'll get the car up and I'll show you how this fit in there, where the transaxle used to set. The motor fits perfectly, leaving all of this room where the original engine used to be for all of the batteries, or at least 3/4 of the batteries.
So which batteries are you going to use?
So since it's a Model 3 Performance motor, that's a 400 volt max system, I wanted big batteries, so a big battery pack, so we're going with the Model S 100 kilowatt hour pack. So that's 16 of the modules. You could use Model 3 modules, they make 400 volts, but they're very awkward in their size. It would take a lot of cutting. The Model S battery modules are perfect for reconfiguring to fit into this type of car. So it'll have a big battery though, 100 kilowatt hours.
And it will bring you to 400 volts.
Yes, 400 volts, and probably on a car that's going to be less than 3,500 pounds, it might even get about 400 miles of range.
We're still with 300 or even more than 300 horsepower.
More than 300 horsepower, yeah. That's right.
Fantastic. Yeah. So crazy specs already. Do you have a rough idea of the weight?
I'm thinking the weight is going to come in about 3,500 pounds, maybe a little bit under, and I'll get it scaled once we get it completed. Okay. But it's still going to have the DeLorean maybe problem or feature, which is mostly aft weight. Okay. This was I think it only had about 35% front weight. It's going to be very similar because most of the batteries are back here where that engine used to be. The car, however, is suited for that because they designed it with a heavier suspension in the rear to help handle all that weight.
Okay. So they solved the issue with the suspension.
Exactly.
Yeah. Okay. But you have the luxury, if you wanted to have slightly more modules in the front, if you wanted to.
Sure, yeah, I can shift. That's the beauty of the electric cars. You can make the weight and balance however you see fit. Mm-hmm. For my purposes, this is not so much of a race car. I'm all about power, of course, so we're getting the performance motor and the big battery, but this has to be a usable car. So I wanted some front space. This is one of the original front cars, so we're gonna still have plenty of storage there. If you do wanna go on a road trip with the fast charging and your storage, this car will do it.
Okay. Before we go a bit deeper in the system you'll be installing, could you tell us the rough timeline when you start a project like this one?
Yeah, so this project, so EV muscle cars is kind of my side gig. So, and I'm working here in my garage, as you can see. This is I have 3 kids and all of our family's things that we have in a normal house. So being a side project, it takes me about a year. Okay. I'm on my final stretch here. A lot of the kit is fabrication. So I do all my fabricating right here, CNC cutting and welding. It's all done in here. It's all done by me, so it takes a little bit of time. But all the fabrication is done. Now I'm in the assembly phase, so I'm in the final month here. We'll get it going.
And probably we should mention your business name.
Yeah, so EV muscle cars. I started out as a muscle car enthusiast. You may know Project Electrolyte, which is my daily driver now. And that was a Mopar, a big Mopar that's Model S powered. And I just keep it going. Muscle cars is where I like to be. This is a little bit of a stray from a muscle car for me, but it's going to have the power that it should. So it's
You're
gonna be
making
great.
it a muscle car.
Making it a
now.
muscle car,
Yeah.
that's right.
All right, let's carry on with the engine bay.
Yeah.
And so you're reconfiguring the engine bay.
That's right, yeah. So when I got this car, it was a project that had already been started, so the drivetrain had been removed. So there's a big space here. And when you're assembling all these components, there's a lot of planning into where everything is going to fit. To me, it has to fit, it has to look good, it has to perform good, but it also has to be repairable in the future. So everything is accessible from either the top side or the bottom side. When this is complete and assembled, this will be all batteries back here. You'll still see a little bit of the radiator, you'll have access to the coolant fill, but this will just be batteries under glass with LEDs. Trying to make it, you know, if you have a car like this, you're taking it to car shows and cruises and SEMA and all the different things. So it's going to have that show aspect as well.
Speaking of cooling, could you take us through the new system you've completely designed?
Yeah, so what I've learned from the electrolyte, and I should mention, so we're in Colorado, we have extremes in temperatures. We have cold to warm sometimes in the same day. So some of the things you have to keep in mind are the battery health. And the biggest thing to keep your battery healthy is a stable temperature. So we're going to have a battery heater, an electric heater. You would normally use that if you're going to, before charging, you want to watch those battery temps, or before driving, you get more capacity if you can keep it in kind of that 25 degrees Celsius range. So the battery heat, but the battery heat uses power. So what I learned on a road trip in the electrolyte, which was in the winter, 30-degree Fahrenheit temperatures, the batteries will cool down because you're not flowing enough current to keep them warm. So that battery heater continually kicks on. So I'll be using waste motor heat to keep the batteries at their happy temperature while driving.
So you have recreated Tesla Model 3/Model Y Octovalve.
It's similar to the Octovalve, yeah. It's nowhere near as complex, but I am using Tesla parts. So what we have here is we've got a four-way valve as well as a three-way valve. The combination of those valves allows me to have multiple circuit flows. So the motor, if you're just max performance, let's say you took this to autocross and you need max motor cooling, it's a closed loop through its radiators. This has pusher fans below it, behind it, and it also has ram air intake from these factory intake locations. So you'll have a ram air while driving and then fans to assist. These both operate in parallel. So I've got 4 fans. We've got almost 2,000 CFM that'll pull across these radiators.
All right.
More than adequate for this motor, which is an oil to coolant cooled motor. It's different than the Model S motor. This has kind of a flooded oil cooling system. And so max performance, we've got it for the motor. Now max charging, if we're going to DC fast charge, we're not running the motor, so it'll reconfigure, and now these same radiators with those fans will be battery cooling when you're pushing all that current into the batteries. In addition to that, it has a AC flat plate chiller. Okay. So the AC can kick on. The reason the radiators are in the back is because the condenser is in the front. So when you're doing max effort cooling, if you're going to run the AC and the radiators, normally they're sandwiched between each other in the front of a car. So if you're pulling heat off with the condenser and put it in the radiator, you're just spinning your wheels. But this way, I can not only pull heat off with the condenser, I can also pull it off with the radiator. So it'll just be max effort cooling because this will have DC fast charging.
With all the effort and engineering this took, is it something you may potentially offer as a kit, as a system?
I will at least have plans available. What I've learned with EV conversions is it's very hard to have a kit that suits everyone. So you can have a process and maybe you can have parts to kind of assemble your own kit, but it's really hard to have a package that you just hand over and it works. But all of this is documented, and I actually share a lot on the internet because I was just a builder trying to learn, and I just want to support this craft, so it'll be out there.
Fantastic. Is there anything else we need to cover in the engine bay?
So on the top side, this is about it. I'll have some finished panels back here to kind of complete the look back here with this brushed aluminum, which kind of plays off the brushed stainless. And then the batteries, of course, will be under glass. This panel will also be under glass. This was a vented engine cover, and this engine cover obviously needed to vent the hot engine bay, but it's got a nice window look to it. So if I cover these in glass and seal it all off to keep the batteries dry, you'll be able to look through and see the batteries just with the louvered cover up. So it'll make a nice finish.
Kevin, did you have to do a lot of modification to the chassis or mounting points?
There's a couple modifications. There was a kind of a strut tower brace back here, but that was going to interfere with how I could package these batteries. So this tray is actually designed as the strut tower brace, as the mounting for the pumps, for the valves, as well as the battery box. Okay. So using factory locations, I'm still getting the purpose out of it, but it's now multi-purpose.
Okay.
So these battery boxes, these are all, I CNC cut these here, and it took me a while to find a battery box that fits the Model S modules to make them kind of universally fit. And the way this box is designed, it's symmetric parts. So once I cut these out, they can be left to right, they can be top to bottom, but we just stack up all of the modules and they're very secure and very modular. So this is one of three back here. Mm-hmm. There'll be two more that'll start from the bottom and come all the way up with bodywork that'll flush it out with kind of a diffuser in the back.
Any particular setup with the cooling system between the three packs?
So all of the battery modules, which I've got one out here, you can take a look. These are the Model S modules. If you look close, they have a lot of density of the cells. So this is from the 100 kilowatt hour packs. And they've got dual cooling loops on these. So every loop needs to flow in parallel.
Okay.
So every box will have a cooling manifold. I've got those over here. So I prefabricate these manifolds, and they're kind of designed to kind of offset.
All right.
Now these will be in every box, and as the coolant comes into these manifold, it equally distributes through every module. So not only is every module in parallel flow, then every box becomes in parallel flow. Yeah.
Is it a setup you've already used in other build?
Yep. Yeah. So the electrolyte has all this proven. This is kind of the next generation where it's a little easier to assemble, because I think the hardest part of these conversions is fitting the batteries, plumbing and wiring the batteries. There's just a lot of complexity to get it to fit into the car. So I'm really trying to make that the easiest part, but it's taken some time.
All right. All right, let's investigate the front, so the frunk, we should say, and the fourth battery pack.
That's right, yeah. So this is, again, an identical battery box to those other three, kind of that modular system. They work together in packages of three, but I can extend it to 6 or 8 or down to 2, so the same box works with all the configurations. My decision point on the full battery pack, I kind of had to decide here, do I want to keep the frunk completely intact and only have 2 more modules up here, but that would cut down the voltage, cuts down the range. I just thought we have the room for it. It sticks up a little bit, but remains almost a complete frunk. So we went with the full 4
and you
modules.
actually gain a little bit of room because you're getting rid of the spare wheel.
That's right, yeah. Either way, the spare wasn't going to fit the same way. Most cars nowadays don't carry a spare. You've got a can of, fix-a-flat or the plugs or whatever you want to carry. But this is going to be perfect location for a charge cord. It's still going to have a nice finished surrounding here with the, again, LED batteries under glass kind of look for show.
Do you have any spare room behind this panel?
Yeah, so under this panel, which is loose right now, I'm going to have my charger, the contactor box, the AC compressor, all of that is going to be underneath, and we'll get the car up and I'll show you all that space. That was the original gas tank. And the reason the gas tank was there, or because the gas tank was there, the gas filler used to be right here on top. What's a little bit strange about that is it's under the hood. Yeah. And so the early model actually had a gas flap here in the hood. This is a non-gas flap hood, which means you had to lift the hood every time you wanted to, or the bonnet, every time you wanted to fill the gas. So you might think, just like a lot of conversions, well, that would be a great place for a charger. But what I don't like about that is, again, you have to have the
Yeah.
bonnet up the entire time. So I'll show you the location we have for that. What this is going to be, however, is the main service switch, the main cutoff. So if you're going to work on the car, this will be mounted down flush. If you're going to work on the car, if you're going to store the car, you can cut the 400 volts just that easy. So it's a good location for that.
Going back to the charger, are you going with CCS1, NACS?
So yes, CCS1, it's going to have the CCS port, but once that's installed, then you can use an adapter to NACS once that's available for everyone, or you can go to use a Magic Dock, however you want to do that. But then most people just charge with the J1772 at home, so it's got that as well.
Yeah, but at least you can go on a road trip. And
Yes, yeah. So this is going to have 200 amps of charging, so 75 kilowatts. And we'll talk about more why we're limiting it to that. It's plenty for a car like this. I did my road trip on 50 kilowatt CHAdeMO and had no problem. So CCS at 75 kilowatts is fantastic for this type of car.
And to be fair, while this charge at the charge, you're going to talk to people all for 45 minutes. You're going to talk to people asking questions about EVs, about the DeLorean, so in particular about this. So
that's exactly
you're
right.
going to spend quite some time at the supercharger.
Yeah, you start getting charged idle fees just because you're sitting there chatting with somebody.
To people, yeah.
Yeah.
It's funny because it feels like John DeLorean built this car thinking it could be electrified one way or another, because you make it sound like it's easy to convert.
You know, the more I spend time with this car, the more everything just seems to fit. This is one of the best cars to convert. I mean, to fit over 300 horsepower and 100 kilowatt hours with fast charging and a PDU, all the wiring will be, you know, modern. It's just, it makes this car even more timeless. It's great.
And you would think, it's funny because you would think the X chassis would be actually more tricky to convert it to electric, but it actually makes it easier.
Yeah, in fact, I'll show you right here under this box. I didn't do any frame modifications. I cut the frunk, but you can see that X-frame, like you were talking about, is just a perfect flat platform, which is a really secure mounting location for this front box. And this car also has, DMC had, I think it was an aftermarket option, but electric power steering. So it's got the electric power steering already installed, which is kind of a challenge if you had a hydraulic steering car. That's already complete. That motor is in the steering column. And then it also has power brakes.
Wow,
I'm keeping the factory power brakes. I'm just going to run a vacuum pump. And the main reason for that is because the HVAC is all vacuum operated anyway.
So it just makes sense to optimize it all.
It makes sense to have it all. Yeah,
perfect.
Exactly. So if we go around to the front here, we can take a look at where that CCS charging port's going to be located. So like I said, the gas filler is usually the normal spot for a charge port, but this car is a little bit different. Looking around the car, you kind of start to get a feel for where things will fit. And I wanted it in the front here. When you pull into a charge station, the easiest way is to just pull in, grab the cable, and plug it in. And so we've got this grill, which actually has kind of the kit car strobing LED, kind of like Ready Player One. In talking to Felton, you know, the CCS kit works perfect with the BMS I'm working with. I'm using the Orion BMS, so I'm going to go with the Felton kit. And this is just going to be a great location for that.
Perfect.
So right here in the middle, this will be a finished panel. This will be motorized. So you just pull in, hit the button, it motorizes down. This took some time to kind of figure out how do you get something to move out of the way, because you got to have a straight in for the plug. So this is the latest in recliner technology. I studied a lot of recliners to get this mechanism to work, but it's going to be kind of a nice
So you are really taking this car into the future on many aspects. Yeah,
that's right.
All right, Kevin, what is this street glow option? Something you installed?
Yeah, no. So we sometimes, you know, a car's been around a while. You do some modifications, and it's been into various shops. Some of it's beautiful work. There's pinstripe LED lighting, all customized interior. Some of the stuff, you know, I'm going to be remounting this. The horn tones, that's actually a sound generator. It makes sounds when you open the doors, or, you know, maybe you want Back to the Future sounds, however you want to do that. So we'll keep that installed just in a better location. And then all my wiring is going behind the seats. And so part of the build is you have to determine what you are working with so that you can now adapt it to the new system, the EV system, and the new PDU wiring harness. So that took me a full week of just tracing down old wiring. We don't need things like idle air, motors and tack inputs and all the things that went back to the motor. So I've eliminated probably 30 pounds of wiring that were unneeded. And everything I need now is labeled to adapt it. So you get in, you're going to drive this car like any car. You get in, you turn the ignition on, hit start, it'll pre-charge, it's ready to go.
So before we jump in, how much work did you do before you even took a bolt out of the car?
There's it's a combination of studying the wire harness. So I spent a lot of time just studying out of the garage. What am I getting into? Choosing the components I wanted to use for this car. So a lot of it is just mental studying work. And then the fabricating, I do a lot of 3D printing. So I've designed some relay and fuse modules that make it easy to, once you've determined where the wires are in this car, now you'll just connect it into my conversion box and it'll mate the two together.
Okay. How good or bad was the 12-volt system when you started with?
Was it Lucas Electric? I think they were known as Lord of the Dark.
That's it.
So it was interesting. I couldn't tell between the original wiring and what somebody had cut and modified to add things like horn tones and sound systems. So it all looked, let's just say, not like they do it today. So there's some challenges with this car, though. This is a mostly fiberglass car. So you've got the X-frame, that's mild steel. You've got fiberglass on top of that, and then it's clad with the stainless steel. So you really don't have a good chassis ground system. So every component has its own dedicated ground run.
Okay.
So I'll be changing that into ground bus bars to kind of have localized grounding points. So it'll still function very well, but I was able to eliminate a bunch of wire by doing that. So again, all the engine wiring that had to be identified and removed, but all of the body wiring, again, 600-mile car that was garaged, everything's in great condition, all the original wires. So once I've got all those labeled, it's easy now to just mate it to the new system.
All right, Kevin, show us what you've done, why you've done it, and why it's the best way to do it.
Yeah, well, so it's the best way I know right now. Like I was saying, you got to trace the old wiring. So you can kind of see what we are dealing with the original wiring. To make this car complete, we were talking earlier, the car's not complete until my wife will drive it to the grocery store. So that means everything has to work. That means you get in and your factory AC, you're going to turn the AC on and it's going to work as expected. So the problem is the AC doesn't work like it used to. This all has to be with the new electric compressor with some different systems. So we have to trace the original triggers of the system, meaning fan speeds, the HVAC, vacuum switching, all of that has to work, but it has to get the new system operating. So once I've traced all those wires down, and by the way, anybody who's doing this has been through this before, this kind of wiring, and it looks like chaos, but it's only one wire at a time. Once you trace one wire and you label it, now you know where it's going to go. It's really not that bad. So this old wiring now has to mate to all the new components. And so all of the new components probably have more wiring in total. Again, it's only one wire at a time. The main component of the battery system is this BMS. This is your Orion 2 BMS. It has another couple components that go along with it.
Let's go step by step. The battery management system will make sure each and every individual cell is at the right temperature at the right time.
That's
constantly, when you're driving, when you're charging, and even in between.
That's right. It's the watchdog. If it sees anything it doesn't like, it will not allow charge enable. It won't allow discharge enable. It'll shut you down until you figure out what's going on with that. It could be as simple as maybe a bad connection, but it could be an actual problem. You might have a cell that's gone high resistance or over voltage, under voltage, and it's going to shut it down until you solve that problem.
Why did you choose the Orion system over other systems?
There's a couple reasons. I've used it before, so I'm very familiar with it. Because I'm familiar with it, I like it. It's got so many options. You can take it as far as you want, even from additional sensors. This thermistor expansion module gives you like 80 thermal points that you can monitor. So you can monitor connections like on the CCS fast charging. If you have a connector that's getting too hot, again, it'll shut it down because it's beyond the battery. It's the entire system. And anything, heat is always the enemy. So if you have something kind of run away, it'll shut it down or reduce current, whatever it sees fit at that time.
Okay.
Another nice module we have with the Orion is this Wi-Fi module. So when you're plugged in and charging, you can log in online. You can see all the stats. It has an SD card. It'll track all the stats. You can go in and log and see all the graphs of everything anytime. So it's just a good solid system. And then the final reason is because with Felton building the CCS system, that works with the Orion. So they communicate over CAN bus. All these are a CAN bus for the battery system for the Orion into the Felton CCS. They just all work together.
Okay, so it makes for a nice package.
It really does.
Yeah. Okay. Anything else you wanted to show us?
Yeah, so the other two components we have there on the far left, that's the EV Controls T2C. That's a very popular Tesla controller. It's a CAN bus based controller. That's going to have a wire harness that kind of mates the car to the motor. So it's kind of a triangle of wiring going to that. You're going to have all your inputs like gear selection, ignition, start, all of those functions will go to that box. But then you've got throttle pedal functions that go straight to the motor. You've got brake input, light outputs, all of those things. So everything that has to do with driving the car goes through that EV Controls T2C.
And the last bits, we've got some EV muscle cars branded relay and fuse boxes.
That's right. Yeah, these I make these. You can go and find relay boxes, but none of them. They're all kind of universal, and I wanted something very specific. So I make these internally. They have 3 bus bars. So they have a ground bus bar, an ignition, and a switched ignition, or a constant power. So switched and constant. I'm able to custom wire these for this purpose. So it also has all the fusing. So just that T2C has 4 or 5 fuses dedicated to it. But then we also have fuses for the BMS. We have fuses for the DC-DC converter, the charger. So everything that I need to adapt from the car to all of these components, they all have their own connectors. It's all pre-wired. So now I can just wire the car, connect it in, and everything is ready to go.
So the more it goes in the EV conversion industry, the closer we're getting to OEM level of integration.
That's right, yeah. Kind of figuring out where you can make things modular, that makes it all much easier, not only to install, but to diagnose, to manufacture, kind of all of it.
Service down the road, yeah.
Yep.
Yeah. So there will be one final panel in the back hiding it all.
Yep. So this will all be enclosed, and the owner of this car, I love his style. He loves some of the gadgets. He loves some of the tributes. So say to the Back to the Future, the most common question I get with this is, where's the flux capacitor? So of course it has a flux capacitor, and he's already got one in there, but I'm going to make it a strobing state of charge gauge. So yeah, it's going to be great. You'll see it just right here all the time.
Yeah. All right, Kevin, what will you be doing with the dashboard? So
the dashboard, I have a couple options here. We can make all of the original needle gauges work. We could go in and relabel them, repower them. And I'm really kind of in talks with the customer right now, because the other option is to use tablets. So with 2 iPad minis, you can see every function in the battery management system. You can also see every function and parameter in the Tesla motor. So you get a lot more information. What it does, however, is it changes the look of the car.
Yeah.
Now we can make it a tribute to this dash panel. We can make all the gauges look like this. So that's still in decisions right now, but we have lots of options.
As long as it goes to 88 miles per hour.
This will finally get to 88 miles per hour.
Excellent. One last thing, Kevin, was this a manual or an automatic car?
So this was a manual. So now it's a single speed, it's the entire drive unit from the Model 3. But we still have a clutch pedal. And I'm going to leave that in place as kind of a security feature. You will still have to depress the clutch in order to get it to start.
Nice one.
So we're underneath the car now, so we can take a good look at this Model 3 performance motor. Like I mentioned before, it makes it a mid-engine because the motor is in front of where the axles would be located. But it fit in so good, we had all this room. What we were able to do is put the motor in front of the original brace where the engine was mounted, and it fits up here where the transaxle used to be located. This did take some custom mounts, and it did take a little bit of cutting on the frame, but it's all been reinforced with heavy-duty multi-piece brackets.
Nice.
All those are CNC designed and cut so they can be reproduced if I build another DeLorean.
You mean when?
When I build it. That's right. Yeah, this is going to be such a good drivetrain. And so in this case, we just used the drive unit. We didn't use any other components from the Tesla because this car has a standalone, swing arm suspension. All we had to do was adapt the Model 3 tripods on the axles to what is a Porsche 930 CV that bolts straight to the hubs on the DeLorean. So that was a fairly easy way to adapt it. This will have a little bit more of extra weight from the original car, so we will update the suspension. The swing arms are plenty heavy. We'll just have to get heavier springs, maybe some modern valving in the shocks.
And with the regen, you don't anticipate needing to do anything to the brakes?
Yeah, the brakes, it could be a performance car. You might be able to push this car harder than you should. So we will upgrade the brakes as well, just to get it up to, this needs to be just a car you can get in and drive it to all the limits. This gives you a good look at those valves we talked about earlier. They're under here. So they are accessible from under the car when everything's assembled. We also have the two pumps. So we've got a motor system pump and a battery system pump. Again, those valve and change circuits, so they kind of serve dual purpose when they need to. So this is another one of the components that's necessary. This is a charger and DC-DC converter combination unit, liquid cooled. This one comes from Stealth EV. And this is going to fit up here where this gas tank used to be. So we've got a nice location here. This has a factory cover, so once it's all mounted, it'll be covered and accessible. Even though this is a low maintenance device, it's kind of the perfect fit in here.
And this is the original plate.
So this original plate covered the gas tank, but now it'll protect all the components that'll be located up there. Also have the AC compressor will be up there, and all of the contactors.
And you cannot tell it has been converted to electric?
Nope. Yeah. So like we mentioned, this car seems to be suited for conversions. One of the things we had to do with the engine is the cooling lines had to go all the way up to the radiator, but I have cooling lines as well, so those have been repurposed now. So these coolant lines are in the original locations. That'll feed the heater core. We'll have more of them on the other side. That'll do all the battery cooling as well.
And what option will you use for the high voltage cabling?
High voltage cabling is going to be double shielded 2-aught, which is more than the motor needs. The motor only needs 1-aught, but it all comes down to max continuous current ratings for that high-speed charging. These custom motor mounts, I wanted to use the factory isolators. It has 3 mounting points on the motor. So to capture the isolator but make it fit into the frame, I did put a window in the frame so the ear protrudes slightly, but then I've got a 2-piece clamping motor mount that not only reinforces the frame, but it isolates the motor so there'll be no vibration. So a lot of the small components that are needed, Tesla also produces. They build electric cars. So I like their components. I like their heater. This is the liquid battery heater that I'll be using. It just goes in line in the battery system. This will also double as my heater core heater. So I have a closed loop heater core function with those valves so that you can prioritize. Do you want cabin heat or do you need battery heat? The other side of it is the chilling. If it's a hot day and you are using the AC anyway, we'll also chill the battery. So this is a really nice component. I like this a lot. It has a solenoid valve with the expansion module here, and then it chills the coolant, which is also inline in that battery system.
So repurposing existing OEM component makes it not only cheaper, but easier and more reliable down the line. Yeah.
Definitely more reliable, yeah. And these parts, if you're getting these components out of a car that's been crashed, all of these auxiliary components are still good as well. So the high voltage system, we mentioned that 2-aught cable. This is the double shielded 2-aught, and the purpose of the 2-aught is for the 200 amp rating for max continuous on the charging. All of these connections have heavy lugs that have to come together in a bus bar that will distribute the power not only to the motors. You've got out to the motor, you have in from fast charging, you also have out to accessories like the battery heater, the AC compressor. And so a junction box, a contactor box is the best way to get all these together. I have the luxury of extra space, so I made a large, roomy box, and I'm using aluminum bus bars, just like the aluminum current collectors on the battery. There's already aluminum in the system.
To dissipate heat.
Dissipate heat, but also carry enough current. You have to size these, so the thickness and the area, these are rated for 350 amps continuous, even though it'll only see 200 ever continuous. And I've made them just flat bus bars. Sometimes you'll see some very creative copper bus bars that are bent and shaped different ways. But these flat plates make it very easy because you can stand them off with the contactors, which is the isolation from the car. So the outside of the box is mounted to the car. The 400 volt system must be isolated from that car. So we will have isolating glands going to everything. But you've got your negative bus bar, your positive bus bar. These see the differential of 400 volts. This also has the pyro fuse, another Tesla part. This has a pyrotechnic disconnect that will blow this fuse if it exceeds 2000 amps. Very simple, reliable, self-powered device. So that's just built into the system. We also have a pre-charge resistor and contactor. Every time you start up the AC compressor or the motor, it goes through a pre-charge, which slow charges it so you don't put extra stress on capacitors and components in the motor. And that's all controlled with the EV Controls T2C.
All right, that covers most of the conversion. So you make it, again, sounds like it's fairly easy. Obviously, you've done this before. But what would be maybe your best tip to someone that's looking into doing his first conversion?
You just have to start somewhere. And luckily, there's lots of videos like this. So watch all the YouTube videos, get into the forums, go to the shows, go to the State of Charge Expo, which is coming up, the Electrify Expo. Just start talking to people, and you'll learn more and more about these things. More information's coming out all the time. My favorite information is the Orion BMS manual. If you go on their website and read through their manuals and extra documents, there is so much information. You won't get it all at once. You got to read it multiple times. I still go and read it. But
I think Kevin has activated the geek mode.
Owner's manual. Somebody already figured it out. You don't have to reinvent it. So, yeah.
Did you follow any training, or do you have any training you would want to recommend?
There's a number of good training systems out there. Everybody from Felton to Hypercraft to a Legacy EV, that's probably the most popular I've been involved with. They're all great training programs, and yeah, you can learn all the safety because you're dealing with 400 volts and high current, and this isn't anything to not take serious. So there is some risk here. You definitely want to be safe when you're working on this stuff.
With high voltage, you only have one try.
That's right.
Yeah. So Kevin, earlier you mentioned you are limiting the charging rate. Could you tell us a bit more about this?
Yeah, that's right. We could, even though we've got a continuous rating on the cable, we can push that rating up to a certain temperature limit. But what I've decided to do is just to stay at the max continuous rating. A car like this, we're going to charge at 75 kilowatts, which is plenty throughout the entire charge curve. And then all the components will be easily able to handle that amount of heat and current. I will also have thermistors on all of the necessary connections so that we can monitor it. If that BMS sees anything starting to ramp, it'll detune that charge curve. But we'll have a very flat charge curve with a slight taper at the end. And that's on the DC fast charge side. The AC side, when you're plugging into the J17728 at home, that's just going to be a 6.6 kilowatts, kind of a standard rating, and that'll be all the way up to the full charge. But the DC side, we're just going to keep it detuned for now. If an enthusiast wanted to push it higher, it's definitely possible. You just have to know exactly where your current ratings are, what your temperature ratings are.
So you will need to monitor it live to make sure everything
You
is
need to
fine.
monitor, yep. And so with the Orion BMS and the Wi-Fi module, you can monitor all those temperatures, the states. If it did see a fault because it went out of bounds, that fault will show up. And that's on the internet, so you can monitor it from wherever you are.
Yeah. Off camera, you were mentioning that all the cabling you will be doing will be with, at least for the high voltage part of it, no one will be able to touch it. It will be straight plug and no connectors.
That's correct. Yeah, everything will be inaccessible to the user of the vehicle, with the exception of the disconnect switch. This is the only access to high voltage they will have. The contactor box is inaccessible, and there are no connectors that they will be able to disconnect. So just monitoring safety. For somebody who doesn't know all the details and what's safe to touch or not, you don't want somebody to go in and start working on something. But the safety switch here, this service switch, this will be readily accessible because that's an important component in the system.
All right, Kevin, thank you so much. Let's real quick mention where people can reach you.
Yeah, so social media, I'm Mr. Mopar Man, back to my muscle car days. So that's Instagram, YouTube, TikTok, all the social media. evmusclecars@gmail.com if you just want to send me a note and chat or have any questions or talk about cars. I can talk about this all day.
All right, guys, if you like what you saw today, let us know in the comments below. If you want to see more of those in-depth covering of builds with specialists, let us know. Again, guys, we'll see you in the next one.